Ladies and gentlemen, please welcome Lou Tucker.
Welcome. How do you do all? So I wanted to talk to you about Cisco and Red Hat, how they're actually working together and bringing some new innovative solutions in terms of cloud computing. And so briefly, we'll be going over where we are sort of with the evolution of the cloud. We're sort of at the very beginning, I think, of a very interesting journey that we're on. And sort of as Brian has talked about, everything is moving as a service. So it's a great time to be a developer because so much of the work is done for us by these other services. But I wanted to dig even a little deeper and to talk about actually how you build services and actually delve into some of the infrastructure as a service attributes of this. In terms of that, I'll be talking a bit about Cisco's cloud strategy and how we're working together with Red Hat. So cloud computing certainly does cover a lot of territory. Whenever I'm asked to define cloud computing, I usually beg off and I basically say, no, it really has these following attributes. We've used a lot of words for this in the past, in fact, software as a service, utility computing. Actually, utility computing is an interesting one because that's been in the industry for maybe 20, 25 years. It's really good actually to be back here in Boston because 25 years ago I was working at a company called Thinking Machines over in Cambridge where we were building a massively parallel supercomputer that had 65,000 processors. So distributed computing's been around for quite a while now. It's interesting to know now we're seeing it arise again, but we're actually getting our computing now in the cloud on the internet today. We've also talked about it as being grid computing, where a lot of the history in terms of distributed computing has come from. And then infrastructure as a service, storage as a service, everything as a service going forward. So in many ways, I think we are at the very beginning of this major shift. And this is a hypothetical adoption curve. I don't know the timeline of this, sorry. And if you've read like Nicholas Carr's Big Switch, the analogy is often made with the transition to electrical power generation that we've seen in the past. And as been mentioned also today here, parts of the industry are already well up on this curve. So startups in particular, I'm now in Silicon Valley, and if you're trying to raise money out there for infrastructure, good luck. They're going to say, pay as you go, get it from the cloud, because it's the most efficient use of capital, in fact, today, when you don't know what the potential is for a business. It's a pay-as-you-go model. And so this even works around the developing countries, for example. When I've talked around the world about this, is that this is a much more efficient use of capital to have service providers aggregate demand for some locale, some region, and be able to provide that kind of computing services out to businesses. So we may start to see the beginning of the end of the closet that has your computing in it. And instead, we're really going to be moving this to service providers. Of course, one of the big drivers of this is the explosion in the amount of information. I mean, some of the numbers that we're seeing now in terms of how much information is crossing the internet every day now. For example, it's 21 exabytes per month that we estimate going in now. That's just 4.8 billion DVDs. So if you were to stack them up, that's about 1,000 miles high. I mean, it's an enormous amount of information that's going over the internet, and I attribute a large part of this actually to my 16-year-old daughter who seems to watch Netflix all the time on her computer, even though I've outlawed watching TV. So it doesn't do any good anymore because they're all getting it through the net. Also, I think we're going to see even a larger cloud on the horizon. As we start to look out, not only just in terms of our laptops or mobile devices, and that we're going into sensors, these are going to be the sprinkler system in watering my lawn, or in the car itself today has over 200 devices that are beginning to get networked. And so it shows actually the real importance of networking as we approach this kind of world, because whereas I may want to use things such as grid computing to have my car peer-to-peer talk about other cars that are down the road to understand what the holdup is or the traffic jam out there, I certainly don't want anybody messing around with my brakes or my steering while I'm traveling down that highway. So being able to handle both security and access at the same time is something that Cisco is working an awful lot on in bringing the kind of networking, the borderless networking that we need in cloud computing. So we are rapidly approaching a time when these are going to be the numbers we're talking about. You know, trillions of connected devices. That's huge. I mean, millions of applications. We see the popularity of app stores now, where you can actually get applications just by downloading this. I was fortunate for a while, I was actually at Salesforce.com and built the app exchange there. And that we were talking about as being an eBay for business applications. I mean, think about it, an eBay for business applications, and that's the kind of world that we're moving into. And we're also then seeing, 1 billion terabytes of content, and data is growing, as you know, faster than almost anything else. So another proof point for why this, how we're seeing this happening, we are talking now about warehouse scale machines. In fact, this is one of Google's data centers, and if you sort of squint your eyes, this begins to look like a circuit board, with chips on it. Well, those chips are now warehouses containing tens of thousands of machines. And in fact, one of the properties of these is that now in these very large web applications that we've seen, you're running essentially a small number of services, maybe a dozen, 2 dozen services, over a very large number of individual servers. So there's a lot of different attributes when you start to think about machines like that. And I know from the thinking machines days, this is where we were trying to go. We were really saying that there needs to be this service, this utility. We had a picture of an Ethernet connection in the wall, and you say that's where you're going to get your computing from. And that certainly is where it's going. So what is it about cloud computing that makes it so attractive, and sort of why now? First of all, we've mentioned you can have the possibility of dramatically lowering the cost of computing. And a lot of this is also getting the economics through multi-tenancy, aggregating a lot of this demand so that you're able to provide it at the lowest possible cost. Also, it's really about getting that software control over resources. In fact, applications now can do their own provisioning. This is a very interesting concept. I think it was explored in some movies like The Terminator, for example, where now software can actually build things, it can actually provision resources for itself. And as you build in economics in it, then actually an application you might be able to give it a goal to either conserve resources or to meet customer demand and be able to scale itself up based upon the cost of computing, which I think is actually a very interesting thing to think about moving forward in this. It's also about self-service. One of the great things about the internet is that we all have actually learned we prefer to do it ourselves. I would rather not file a trouble ticket to have somebody go do something that I could just as easily do myself through the internet. So self-service is an integral part of this. At the end of the day, though, what I think it really gives us more than anything else is this notion of agility. So rather than just cost savings or any of these things, you really are able to respond much more quickly to changing environments, changing business conditions, and so forth. So to summarize, I actually think now cloud computing's biggest drivers are these 2 guys. So Gordon Moore, we all know about Moore's law that is continuing to hold to drive down the cost of computing, essentially cutting it in half every 18 months or doubling the number of transistors. It has a lot of different manifestations, but that is continuing unabated. And that is continuing to make more and more computing available to us, and therefore we're applying it to more and more problems. Also, though, we're now, we're bringing in sort of Adam Smith's market economics of this. We now have a market price for computing. You can go out onto the market and you can say, how much does an hour of computing cost me? And you can get a market price from a couple of different vendors. That's extremely important, particularly in terms of the enterprise. Because enterprise businesses generally are large IT shops, and previously had compared themselves against each other. And they had sort of like, well, how much does it really cost you to do this? And they, were in, probably a couple of dollars per CPU hour and things like that, feeling pretty good about it. Now all of a sudden you've got Amazon, you've got Terramark, Savvis, you've got others coming out, and they've dramatically lowered the price through multi-tenancy and some of these other things. And all of a sudden the IT department's going, why is it costing you 5 times more? What is it that they're doing out when they're aggregating demand and multi-tenancy that we should be doing here to meet those kinds of requirements? So this is really changing things quite a bit. And I also, as I mentioned before, I think as we start to build the economics into it, programs will know how much it costs to run. And that'll be one of the metrics. You not only have an SLA, you will have basically a performance interest, but you'll also have basically a way to know this application is costing me so much to run right now. And that if it has to scale up because there's increased demand, that may be good if your model supports it, or you may be able to say, no, I can't afford to have that grow up or scale down or whatever. at the end of the quarter, you may want to say, I really would like you to conserve some money for us, please. It's really a bad quarter, whatever. Please, reduce some of these SLAs or whatever so that you can actually see the cost come down. So I also think that because of, particularly around regulations, different kind of requirements, data sovereignty issues as you look around the world with different national boundaries and everything, we're going to see a world of many clouds. Whereas I do believe we will see a few very large providers. I think there's plenty of opportunity, and that particularly we're seeing these kind of communities of interest clouds start to form up. Banks, for example, are getting together. They would like to be able to go to a service provider and form some sort of a consortium where it's just banking interests that are in that cloud so that they can meet certain regulatory requirements. That makes it for a very different kind of a model where you now want to have all of these clouds connected and talking to each other. So all of us actually think there's also this other thing going on, which is architectural convergence between, if you look at the way web applications have been built, as we mentioned, massive volume of user requests, and the scale-out architecture versus what you see in the enterprise. So this is very different architectural models that are at play here. And I think a lot of the innovation, as we know, is coming from the web into the enterprise. And in fact, if you think about cloud computing, I think it sort of combines the best of both. That in cloud computing, we're actually taking some of the principles of very large-scale web applications and applying them so that now we can run a large number of perhaps smaller applications on top of that and get the efficiency of web applications. So we're using web architecture across all applications to be able to get the kind of scale that you would like and efficiencies of web applications. So in terms of that, everything starts to become a service. And NIST and others have sort of come up with this software as a service, platform as a service, infrastructure as a service. And in fact, I think the best way to think about it is everything is as a service. Because when you're developing an application, you're actually drawing upon a lot of different services, and this will increase over time. You will have the kind of core compute, networking, storage services, but then you also have the database services, block storage services, metering and billing, and all of those things. And that's the way modern applications are going to be built and are being built today. So here's some sort of model just to show that in terms of if you have an infrastructure as a service layer, you've got individual applications that are built in a very traditional model in terms of a lamp stack. Some are presenting themselves, though, as other services. And here, for example, I have one of those services, which is a platform as a service, allowing now additional applications to be built on top of this in any way that the developer wishes to. So in this model, APIs rule. The APIs really matter. The APIs say to the application developer what you can do. So I wanted to come now back into Cisco's cloud strategy and why we're involved in this. Well, most of you probably know Cisco as a networking company in terms of switches and routers, but we also build systems, and our unified computing system is a very interesting one for cloud computing today. So we really are in the business of making essentially the building blocks for people who are building clouds, be that private or public clouds. We also are involved in trying to find innovative ways for people to be able to use cloud services. This is through many different devices and be able to access this in a very secure way. And of course, and the reason why I'm here is to show that we actually also partner very strongly with a lot of the rest of the ecosystem to bring full solutions out into the marketplace. When you do this, I think that what we really also are focusing on is that at the end of the day, it's the user's experience that matters. And this is why networking actually is very important, because you have to be able to deliver that experience out to somebody who's consuming the application. And therefore, whether it's infrastructure, services, or solutions, we're always trying to keep that end user experience at the center and make that the core to providing a good experience. So let's go a little deeper at this point now in terms of infrastructure as a service. We all talk actually about how easy it is to use clouds. And as a developer, I mean, it's so easy now for me to be able to spin up virtual machines and get my things going. But building a cloud actually takes some thought. And it actually takes a fair amount of work in architecture and everything else because you're building something rather significant. Now, why should even traditional data centers look at this? I was talking to one of our CIOs the other day, and we were saying, well, what's wrong with the traditional data center approach? Why isn't that as effective or as efficient as cloud? And it goes along this kind of thinking that when you start to lay out a data center and you bring in different applications, a corporate application, marketing application, finance, engineering, each one has these kind of micro-architectures. You build it on top of an operating system that defines oftentimes the physical system that you want it to run on, the storage environment and everything else. You have these micro-architectures, each one of which is slightly different. In a way, they may be over-optimized because they're forgetting about Moore's law. They're trying to get the maximum performance for that application, and then they're actually having to over-provision in case they have a high peak. So we have this kind of microarchitectures that at the end of the day means that this poor guy who has to run the data center, the DevOps guy actually is left with very inflexible infrastructure and very poor utilization. There's no way for these applications to shift off of those microarchitectures. You cannot share the resources across them. And so by its very nature, it does not scale. And this is because we've actually let the complexity of applications affect how you're building infrastructure. In the cloud model, it's different. We really are defining, as many times as computer scientists we do, another level of indirection, another layer, and now isolating the infrastructure from the complexity of the applications. By having this cloud infrastructure service layer, we can now independently evolve the applications, having them grow as they need to from the underlying resources. This means a much more efficient operation. And in fact, if we start to think about this, even running this on-premise within an existing data center as running a cloud infrastructure service, that service's responsibility is only to run essentially a cloud application, the cloud infrastructure service. And the complexity of the applications is kept out of this. Therefore, they can automate that very highly. They can actually get very good at provisioning, and they can run it just as if you would be getting that service from the service provider. From the application point of view, now you can actually measure how effective you are at running your own service. And you can now compare that again with the market price of another service provider to make that proper trade-off of what you are running internally and what you might be using as a service center. So how many of these infrastructures do you really need? Well, you can say I need something for infrastructure as a service, something for my virtual desktops, something for unified communications, and so forth. But again, this is falling to that trap of over-optimizing for a particular application area. Instead, you'd like to treat this as a pool. And this is the direction that Cisco is taking with their unified computing systems, that we're making this as a pool of resources that can scale very, very large and offering then a multi-tenant service delivery platform on top of that, so that you don't sacrifice any of the efficiency that you want to get the kind of application complexity and performance that you need. So Cisco's UCS system actually is very efficient pooling of these resources, and it's also run completely by an API. So the management of this is done completely through software. And just to speed up through this, it also has this notion of wire once architecture. Since we don't really know the applications, we're not going to be designing specifically for the applications. Instead, we're going to be designing for actually the SLAs, the performance that we want. And so that we can actually define how much bandwidth we want to be able to use and wire this once up at the beginning. Just to go a little deeper, there's other issues that when we enter into virtualization and networking. For example, networking traditionally ends at the level of the server. And your network engineers, security engineers, and everything else focus on securing that endpoint. Well, now on that endpoint, you, of course, have multiple virtual machines. So what we've been doing in terms of this kind of fabric extender, the fabric extender actually takes what would be a line card and a switch and puts it at the top of rack and being able to allow us to now extend that management, simplifying the management all the way down to the individual host in the physical world. In the virtual world, though, we have now this issue. We've got these multiple virtual machines. So when you have multiple virtual machines, you want to be able to take that same concept and extend it all the way through to each virtual machine so that you can apply the same network policies and everything else now to the new center of the application, which is a virtual machine, rather than that host, which was previously connected. This means that, in fact, what we're doing is expanding this domain and getting rid of the need to have somebody independently manage the networking on each host, which is generally then, in this case, done by a person who manages the server. Instead, the responsibility again falls back up into the network engineer being able to provide that kind of security. So I think that's just a brief overview, and we've been working with Red Hat in terms of this. So the KVM supports this model of having this kind of flexible extender, being able to go out into the virtual machines itself. And I look forward to be doing this and other things as we move forward. So thank you very much.